G is being mapped from set B to set C. They are functions which are both one-to-one and onto. Show that G of F is one-to-one and onto. So there are two ways we can really do this proof. All right, so let's write down what they say. They tell us that the function f is such that it maps set A onto set B. All right, and the function A maps to set B, and the function G is such that it maps set B onto set C. And so this is what we know. So what's going to happen? So G of F, that function is going to be such that it maps set A, where is G? G is this one. So G of F, putting F into G, okay. So G of F is going to map from B to C first, all right. So let me start it with this proof then, the function G of F. All right, so what I'm going to do is I'm going to do it by example, right? You can do it by example. Give F some values then, give F some values. So you can give F the set. Maybe you can make F be, let's make it easy and write P, Q, R. This is in the set A, and in the set B, we have maybe 1, 2, 3. All right. Let this be the function f. All right, doing it with the example. And they said that f is one-to-one and onto. All right, so let's make P map to 1, Q map to 2, R map to 3. All right, this is f. Let this be f. All right, and then G now, we can make G be something like, well, B is going to be 1, 2, 3. All right, 1, 2, 3, and it's mapped to some new set C. We can let set C be maybe A, B, C. All right, let's set C be A, B, C. So 1 will map to A, 2 will map to B, and 3 will map to C. All right, so G is also one-to-one and onto. Remember, they said that. So this is the function G. All right, so now they want G. What did they want? I think they want G of F. They want G of F. So they want us to put F into G. So G of F. So they want G of F. All right, so G of F is what they want, which they want us to put F into G. So we're on the domain of F. So G of F is pretty much this. G of F is going to be putting in F into G. So this is what you're having. You're applying F first, and then you're going to apply G. All right, you're applying F first, and then you're going to apply G. So you have, this is A, this is set B, and this is set C. All right, and so applying that, you're going to have P, Q, R, set B, which is we defined as 1, 2, 3, and set C, which is A, B, C. All right, so P maps to 1, Q maps to 2, R maps to 3, 1 gonna map to A, and 2 gonna map to B, and 3 gonna map to C. And so in reality, G of F is such that it's just mapping set A to set C. That's what G of F is doing. It's just mapping set A to set C. So finally gonna write it down here that this is G of A, G of F. G of F is this. So G of F is P, Q, R, and it's being mapped to A, B, C. All right. This is using examples, and so hence as we can see, so we can make our conclusion now. Let's write the conclusion over here. Conclusion. So hence G of F is 1 to 1 and onto on the domain of F. It's always on the domain of F. All right, as we can see, it is 1 to 1 and it is onto, but it's on the domain of F. All right, it's on the domain of F, and you can even add a little further note. You can say as G of F will map set A onto set C. All right, that's what G of F do. That's one way of doing it. Now let's look at the alternate method right here, or, right? Let's look at alternate method, or. That's one way to do that question. The alternate method is you're going to do a lot of discussion. We're going to show them that we have our knowledge about functions, right? So using your knowledge, since you know that you have your knowledge of function, it told us that F is 1 to 1 and G is 1 to 1, comma, so the composite function G of F will be on the domain of the inner function. It will be on the domain of the inner function F, put in bracket, that is set A. And since both F and G are 1 to 1, then G of F will also be 1 to 1, but on the domain of the inner function F. Hence, G of F is 1 to 1. Right? This is if you wanted to show them that you have your functions knowledge, you know what you're talking about. It's always on the domain of the inner function. So you can tell them that. All right, nice and easy. All right, soft. You can go ahead pretty much and tell them the same for onto. You can tell them that F is onto. So you can tell them that F is surjective. F is surjective and G is surjective. Right? And so the composite function GF will be on the domain of the inner function F, that is set A. And since both F and G are surjective, just remember that's what onto means, surjective, then G of F will also be surjective. But on the domain of the inner function. Hence, G of F is onto. Right? Nice and easy, soft. All right, that takes care of the first part of this question. All right, this functions question, nice and easy, soft. All right, let's look now at what's happening with the next part of the question. Part 2. Part 2 says solve the following equation. So we have some equations to go ahead and solve. So we're going to solve 3 minus 4, so part A,